And here we go. So we have NFL data. Iloc. We're gonna go with 68. Actually, no, we're gonna go with we're gonna go with 68. Then in a separate, we're gonna call the rows in a second square bracket. And let's print that value. And let's run that. So there's 7.8. And then the next thing that we isolated was points per game. Again, we use iter tools, group by function. Let's run that. And they are 1, 2, 3, 4, 5, 6, 7, 8th in points per game. So far, looking at 2010, 11, and 12, we see that some of the constant or common variables to look for are points allowed and points per game. But let's keep moving. So now we're running to 2013. Let's do the same thing that we did before. Iloc just means location. And now we're looking at the Seattle Seahawks. Let's go to the next cell. And now we're looking for rushing yards per game. So the top 4 rushers were the Eagles, the Bills, the 49ers, and the Seahawks. Let's go to the next cell. Now let's do winning percentage. Let's actually put that in the cell above. I was just doing that to illustrate that these were the 2 Super Bowl teams. Yeah, nothing really happened there. Alright, next let's look at PD. Because you can see here 186 PD looks pretty high. So we'll do PD stats. Those NFL data again. We're going to do location this time because we're actually going to label our column. 124 and 108. And we'll do team. And the variable we're looking for, which is PD. And let's print that out. And run it. Too many indexers. Ooh. Oh, that's why. I didn't close the square brackets. Let's go back to it. Python is very case sensitive. And here we go. So the top 2 teams in PD, which again were the Super Bowl teams that also had the top winning percentage, were the Seattle Seahawks at 186 and the Broncos at 207. Next, Let's look at some of the top statistics in general. So let's go Seattle. Let's just call it top stats. View NFL data. Again, dot location. 124. You got to double bracket it. And the first thing that we're looking at is rushing yards per game. So let's just copy paste that, like so. Put that there. The next one is yards allowed. I made the same mistake. There we go. The next one, yards allowed. Location 124. And then we're going to do yards allowed per game, like so. Bam. Just make sure we're doing this right. Alright, let's see what the issue was. Oop. Very case sensitive. So when you paste it, you can't paste it like that. Too many indexers. Let's see. See if you can do it like this. Alright, yeah, we'll do it like that. There is more, but I just want to make sure that we can do it and that it works. Yeah, perfect. So let's do it like that, actually. That makes it a lot easier. So, yards per game, yards allowed, rushing yards per game, and points allowed. So that's the last variable that we're looking for, is points allowed. And we'll just copy paste it up here. I'll make it a string. And let's print it. So these were the top three stats: rushing yards per game, points allowed per game, and yards per game, or yards allowed per game, I should say. And let's move on to, let's see our notes. Move on to the Patriots of 2014. Before we do that, NFL data, .iloc, and 128. And there we go. So the New England Patriots here. And let's go to the next cell. And let's paste it in. So, just like we did before, we have number one stats. So, looks like a lot, so let's break it down. So we did the same thing we did before, number one stats, we just did it a little differently. instead of doing it like so, we had it where NFL data location is just called twice. So we get more information. We get the name PD, the type is an integer for both. 128 is the variable, PD. 124 was the PD, and the field goals made is 25. Then we have points per game, top points per game stats, NFL location. We have the label as points per game, and we call 148, 140, 145, 144, 128, which are the rows of the teams that equate to the Packers, the Broncos, the Eagles, Cowboys, and the Patriots. And finally, we do the top turnover percentage, which they were top 3 in turnover percentage. And we have the Seattle Seahawks, the Green Bay Packers, and the Patriots there. Next cell. Let's go to our notes. Just make sure, because the Broncos won multiple times. The Patriots won multiple times. 14. Alright, so that's not yet. Alright, so next we're doing 2015. So let's do the same thing we did before. Iloc, because we're just looking at the integer itself, 172. And we have the Denver Broncos. They won, percentage points, all that jazz. Let's go to the next cell. And we're going to do, let's just do Denver num1 stats data dot location, because we're going to call the labels. We have to double wrap the bracket. First variable is yards allowed per game. They were number 1 in. We're going to do the same thing, location, 172. Double wrap the square brackets. Call team, and we'll close the brackets, and then let's print that value, and let's run it. You can see yards allowed, 283. And what I'm actually going to do is what we did for Seattle Seahawks, because we have more values to go over for points per game. Right here, I'm going to do it like that. Because some of their other top stats were points allowed, actually no, what we're going to do is we're going to see how they ranked against the other teams that year. Again, if anyone's a football fan, this was Peyton Manning's last year, so he was kind of on his last legs. But because they had Von Miller, they just did really well. 240. Oh, no, wait. Going too far on my notes here. 164, 173, and 172. Team and points allowed per game, right here. And let's run it. And here we go. So here what we did was we have those top 3 teams, and then we get a breakdown because you use this comma here of everything that they did. So all we wanted was points allowed per game, but because we used that extra comma in the closed brackets instead of putting it in the open brackets right here, we got everything. So we got the Bengals win-loss percentage, which is okay. It's okay. Let's break it down, right? Win-loss percentage, 75, 75, and 68. PD here. And let's go down here to points allowed per game, which is what the stat we were looking for. 17.4 for Cincinnati, 17.9 for Kansas City, and 18.5 for the Denver Broncos. And let's move forward. Same thing we did before. Iloc. Now we're doing 240. Or no, wait, no we're not. No, we're not. We're doing 192. We're getting 2016 stats. There we go. And let's copy paste. We have their number 1 stats and their points per game. Number 1 stats, win-loss percentage, 87.5. That's a float. The difference between a float and an integer is that floats have decimals and integers are whole numbers. Turnover percentage, this is another one here with 15.6. I'm sorry, 4.9. Points allowed, 15.6. It's another float. And then we looked at the top points per game. Let's change that. Here we go, points per game. Falcons 33.8, Saints at 23.9, and the Patriots at 27.6. Moving forward. Now we have the 240. It's the Philadelphia Eagles at 2017. And let's look at their number 1 stats. Let's just do Philly number 1 stats. We'll have that be NFL data dot location. double brackets, 240. And then we're going to look for possessions per game, which they were the number one at. Which means they had a pretty good defense. And instead of calling the team because you already know it's Philly, let's just print that out. And there we go. Point about 54%. And now let's see how they ranked in PD. Philly PD stats. Same thing we did before. Location. And we're going to get the top two teams. So 240 and 224. And we're going to put in the second bracket team and then the variable we're looking for, which is PD. And let's print that out. Ooh, what happened? I keep on forgetting to do that. You have to, if you do it, you have to still close it in double brackets. There we go, top two teams in PD, which ironically ended up playing in the Super Bowl, 162 apiece. And now let's look at points per game for 2017. Location 352, 240, and 224. Close it. And then we look for our points per game, which is right here. And paste it. Oh, forgot to print it. Can't observe things without printing them, of course. Top 3 points per game, Bills, Eagles, and Patriots. And then finally, let's do points allowed for 2017. And we'll do NFL data, not location. Oop. 244, 232, and then 240. And then, yeah, team. And then we're going to copy paste points allowed. We'll print that. See here, top 3 points allowed, Vikings, Jaguars, and Eagles. If I remember correctly, I think the Vikings ended up playing the Eagles in the NFC Championship game that year. Again, these are all things to note because when we think about our model, when we get to the end of these breakdowns, our model is going to have to look at a statistic that will determine who's going to win the championship next year. 256. Patriots again, that was 2018. Let's go to our next cell. Let's run that. Here we go. So the top percentages for the Patriots. They were top 4 in points per game, top 5 in rushing yards per game, and top 4 in turnover percentage. Moving on to 2019. Before we get to 2019, let's isolate our values again. 300. 2019 Kansas City Chiefs. Let's go to the next value and paste in the stats. Like so. They were 1, 2, 3, 4, 5, top 5 in points per game. 1, 2, 3, top 5, 6 in points allowed, and 1, 2, 3, 4, top 4 in passing yards per game. And now let's go to 2020, the COVID year. A guy who's a staple of championships, Tom Brady. That was his first season. Buccaneers. So let's break down some of their number 1 stats. See what we find. Points allowed. 2020. NFL data dot location, because we're looking for variables, or sorry, row labels. 349, 325, 324, 336, 321, 322, and 345. And we're going to do team, and we're going to do points allowed. And let's print that. Next, points per game, 2020. Location. So just before we even print it out, you can see that they were a lot better on offense than on defense that year. Top 3 in points per game. Top 1, 2, 3, 4, 5, 6, 7 in points allowed. Still top 10. Next, we have the Rams, the second team ever to win a Super Bowl in their home stadium. The Bucs were the first. See there. Go to the next cell. Here we have a new one, passing TDs. We haven't done that one yet for 2021. And spoiler alert, it was the Rams. Use the double bracket. It's okay that it's a it's okay that it's an error right now. It'll be fixed. And let's print that out. .41. Quite a bit of touchdown passes. And next, let's do points per game in 2021. And although it seems tedious to do this over and over and over again, you're able to get a massive breakdown on your data set. And remember, it's not just NFL. The NFL is the thing I picked. Really, this applies to any kind of data set, whether it be economic statistics, healthcare statistics, stock market, crypto prices. It doesn't matter. It's the same type. It's going to be the same exact type of mechanism to find out your statistics and then create your model. And then points per game. And the type of data science you utilize, just like the type of CV you utilize, will determine the type of model that you utilize when we get there. And let's print out those variables, those values. And they were 1, 2, 3, 4, 5, 6, 7, 8, 9, it looks like. 2, 3, 4, 5, 6, 7, 8, 9. They were 8th. We're tied for 9th, or tied for 8th, you should say, or I should say, in points per game. And then finally, we are at the Chiefs, last year of our data set. Kansas City Chiefs here. And let's paste that in. So here we go. Actually, before we do that, let's get rid of this. And let's put that in a separate cell. Preferably a cell above it. And before we do that, actually, let's just do tail. Just like we do with head. Because here we're looking at the holistic overview of the last teams of 2022. And then we can do that. Let's actually just do it underneath it. Actually, instead of doing that way, let's go back to this one. And then go down here. Because we see that they already were number 1 in points per game. As you can see here with 29.2. Passing passing yards per game, 297.8. And that's the team. Then we're going to isolate with the group by utilizing values here with the Lambda function. Passing touchdowns 41, 82.4 for win-loss percentage, 297.8 for passing yards per game, and 29.2 for points per game. Alright, here's what we're going to do now. Now, let's isolate the number 1 values, or the number 1 variables for these teams. We kind of went over it a little bit. So we look at points allowed per game, 2010, points allowed per game, playoffs, 2011, turnover percentage, 2012, yards allowed per game, and points allowed per game, 2013, PD as well for New England, which kind of equates to points allowed, if you think about NFL statistics, because really PD is just point differential. Yards allowed per game was 2015. Again, that equates to points allowed per game. And they were top 3 in points allowed per game that year, as you can see above. Points allowed per game 2016. Points allowed per game 2017. Points allowed per game 2018. Passing yards per game, points per game, and points allowed per game 2019. Points allowed per game 2020. Passing yards and points per game 21 and 22 points per game. So looking at that, let's now get to our model. So the AI model that we're going to use here is a linear regression model. So let's make our model. So our prediction is the 2 variables that determine a championship are points allowed per game and points per game. So let's use scatter plot here. So here we scatter plot points allowed per game. I do have to make note, we're going to have to make another scatter plot for our line because these are float variables or float values, and these are strings. But that's okay because we have the year. So let's do that now. We're going to create our regression line. And let me go over what this all means. So while that loads, first thing that we do is we're going to have our values, x and y values. Same here as well, right? Our x and y values. And basically here's we're getting our slope. So this is our slope. And because it should be a negative slope line because it should be closer to the left than to the right, given that points allowed should be lower. But we do have a lot of dots that are close to the line, which is good. And here we're going to map out our model. So we create a function for slope. And if anybody remembers slope, it just is y equals mx plus b. So we have slope times x, which is the m, mx plus b, which is our intercept. We have my model. We're going to map out the function. Then we're going to plot, just like we did above here. We're going to plot, print that out. And then just to make our compiler able to draw, like I brought up earlier with the runtime, we're going to use our sys, and that's how we're able to draw. All right, let's go next. So the next thing we want to do is we want to test the relationship. And this is for defensive stats, by the way. So you want to test the relationship and see what we get. If it's closer to 0, then we cannot use this model for prediction. If it's closer to 1, then we can use the model for prediction. So 0.70, it's a pretty good prediction. Next, let's look at offensive statistics. So let's list out our years again. our Y values, 15, wait, no, I'm looking at the wrong thing, not 15. 15 points per game on offense would be pretty bad. 4.6, 9, 26.1, 9.2, 22.2, 27.6, 28.6, 27.2, 28.2, 30.8, 7.1, and 29.2. Next, let's plot our scatter plot. Plot that scatter for our X and our Y values. plt.plot X and my model. And then we're going to show it. Sorry, my W key doesn't work well. And let's run it. Oh, it's std out. So as you can see there, it doesn't look like offensive statistics does a great job. But let's test the relationship. And yes, we did skip a step. And instead of plotting with just teams, instead of plotting with teams and then plotting with years, we just skipped the years. And let's test the relationship, see what we get. Change our X and our Y values. So our model is only 0.66, so it's not that bad. We could utilize it if we had more statistics and we kept running our model over and over again. But our prediction at 70 is a lot better. So I would say, and let's write out our summary. Just put it here. And predicting a champion, points allowed per game has a 70% indicator of Super Bowl champion. So bet on defensive stats over offensive stats. Alright, so now let's get to the fun part. You see with DraftKings and all of these other DraftKings, FanDuel, fantasy football, it's taken over the world. So, because of that, our next model is going to be on fantasy football stats. So we're going to do the same thing we did before. Read CSV, weekly points, data CSV, and let's make it a data frame. And here we go. So now we got to break it down. And before I break it down, we have to understand, well, let's actually do this too. We have to understand what makes up a fantasy football team. So we have a quarterback, normally 2 running backs, 2 wide receivers, a tight end, and a flex position, which is a running back or a tight end, and a defensive player. And then sometimes, I don't know, I've never used DraftKings or FanDuel or anything, so there might be a kicker, I'm not sure. But what I do know is the most important things are everything else besides the kicker, even the defense. So, now that we've described what our data set looks like, it looks like our average points are 514. What's our count? Our average mean 7.9, and obviously you want to be above average. And our max is 25.6, total 429, 50%, 6.95, above average would be about 10.5. But let's break it down. Let's see what we get. So, first thing we're going to do is we're going to look at quarterbacks. And we're going to create a data frame for all the quarterbacks. So here's our data frame of all the quarterbacks with the name, the team, the average, and the total points. Well, when you think about what you want to do, right now we're about week 7, week 8. Depending on when this video drops, it could be week 9. Looking at what you want to do is in the future, so you want to have projections. Kirk Cousins, torn ACL. Aaron Rodgers, who's also on this list, I think, or he actually, I took him off actually. No, he's right here. This is from last year. He tore his Achilles at the beginning of the season. Kyler Murray hasn't played at all this year. PJ Walker's currently playing, but he's a backup. So we want to get a little bit in depth with what statistics we want to look for, because this massive data set for 2022 is not going to help us for what our week 9 prediction is of who we want to have play. So, as you can see there, I put Kirk Cousins tore ACL. Here we know now 2023 points and what average is, which is 103.4. We want to have a quarterback that's above average. So the next thing we're going to do is we're going to create a data frame for players that are above average. So here's our scatter plot of quarterbacks above average. Jordan Love, Sam Howell, Josh Dobbs, again, they're in the lower range. Brock Purdy, which is, a little bit above average, according to the scatter plot. Wilson, which is Russell Wilson, not Zach Wilson. Tua, he's above average. Because if above average, if all these quarterbacks are above average, at a median of 103.4, we want to have above average of the above average. So I'd say that's about above 120. So we have guys like Brock Purdy, Russell Wilson, Tua, Lamar Jackson, Jared Goff, Justin Herbert, Kirk Cousins, although he is injured. And I just want to put that at the top. Kirk Cousins recently tore Achilles. Trevor Lawrence, who is, a little bit under average for the above average. Justin Fields around the same thing, and then Hurts, Mahomes, and Allen, who are the top. Moving forward. Next, let's create a polynomial to see if that's going to be our model. This trend line right here tells us that this is not a good model. Our line should be straight. When the line is curvy, that means you cannot use this prediction. So as you can see here, a little fast. Well, I didn't write it down, but polynomial cannot be utilized. So let me write that out. Polynomial is not a good predictor for fantasy football stats. Alright, moving forward. So next we're going to do top defenses. Obviously there isn't much you could do with this, but we can create a data frame to determine the defenses that you want to play. Again, I want to go for top 10 or even above average. So if there's 32 teams in the league, you want to go for at least this. So the defenses that you want to utilize are the Cleveland Browns, Dallas Cowboys, San Francisco 49ers, Pittsburgh Steelers, Baltimore Ravens, New Orleans Saints, Detroit Lions, Philadelphia Eagles, Kansas City Chiefs, New York Giants, Buffalo Bills, Jacksonville Jaguars, New York Jets, Tampa Bay Buccaneers, Seattle Seahawks, Atlanta Falcons, or the Miami Dolphins. I'd say Miami is middling, but they are getting players back. So I'd still say about Atlanta or above. Alright, moving forward. Now we get to the meat and potatoes of fantasy football. And by the way, I just want to make note that all of these stats are PPR leagues. And anyone that's not a football guy, basically what this is PPR means points per reception. Alright, so first we're going to create a data frame for the running back position. Alright, so it's a lot of information. So now we have to make sense of this info. So we're going to scatter plot it. And we're also going to get the mean, which matters more. Because as you can see, it's all over the place. We have so many names. It's such a big, plot. So we have average is 14.05. So the next thing we want to do is we want to make sure that our values are above average. So we're going to have a bar graph now. And we don't have to keep importing NumPy because we already imported it. Oh, never mind. I was wrong. And as you can see, 67.005 is the average running back total. So here we have the average running back, average output. And here we have the average total. And this is the bar graph for above average total running backs. So we have Christian McCaffrey at the top, Raheem Mostert second, Etienne third, Zach Moss, and then Kenneth Walker, it looks like, as our top 5 guys. 1, 2, 3, 4, 5. So those are the guys you really want to look at. Next. Oh, let me put that too. Again, this is through week 7. Now we have the top receivers. Just the data frame. Now we have all these tight ends. Let's work with this tight end set. So we're going to call it tight end bar graph. Let's call them by their last name. Hawkinson. Hawkinson, Andrews, Laporta, who at the time recording this video, he had a great game last night. So his statistics should be up from this number. Oop, didn't mean to do that. And now we're going to create our Y values. And these are updated. These are updated for week 8 averages. And sorry if this video is getting a little long. It's just a lot of information, and a lot of information that can help you get a job, especially in this AI field, which is booming right now. Alright, now because it's such a large data set, I have to change the fig size. I go with 22 and 12 just for now, but we could adjust it later. Now let's do plot.bar, plot our X and Y values. And if you wanted to get fancy with it, you could make it, X tight end and Y points or averages if you wanted to. It's really up to you. I think it's already pasted. No, it's not. Yeah, I figured it'd be mismatched shape because I missed pits. No, I didn't. Shoot. Huh. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh my goodness. That's why, because there's a lot more. .5, 14.6 would be Hawkinson, 15.4, 11.8, 0.6, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have to have 11 values. So 1, 2, 3, 4, 5, 6, 13, 10.6. This is why you copy paste more, because I wrote this down on a piece of paper and I lost my track. And now I got an error. Damn it. Alright, here's what we're going to do. Instead of creating another bar graph, we are going to do the tight end median. So we're going to get the tight end averages. Which is our Y value. Let me make sure it's in a list. It doesn't have to be in a list. Let's print that average. 11.7. So it needs to be higher than 11.7. And before we do that, let's get the average here. These values. Average wide receiver. Average equals numpy.mean. We got a double comma somewhere. $15.7. So we want receivers that have above average of 15.7. We want tight ends that have above average 11.6. So finally, the last thing that we're going to do is we're going to create a massive bar graph for the players that you should play that are above average. Let's update this. Instead of 10.6, it's going to be 11.7. Wide receiver is going to be 15.4. And running back remains the same. Oh. Never mind. Let's delete this cell. Because the average is 14.3. And this massive bar graph are the players that you want to play. So, to conclude, for dataset 2, we tried line regression or linear regression. It didn't work. Because it didn't, we're going to graph out the details and formulate a list of high-performing players that are above average. That's what we did. And that is Python data science AI for the NFL.